Engineering geomorphology to roadway erosion mitigation design. And the presenter is Caroline Ogg, and she's a surface water engineer working for Cohan and Houston Inc. in the Denver office. Ms. Ogg has 6 years of experience in private and public sectors with a focus on hydrologic and hydraulic analysis, erosion mitigation, flood mitigation, and drainage system design and analysis for both small and large-scale applications throughout the Southwest. Ms. Ogg has significant experience with two-dimensional hydraulic modeling, scour analysis, and drainage infrastructure design. She holds a bachelor's degree in engineering science and interdisciplinary liberal arts from the Colorado State University, and is an advisor for the CSU chapter of Tau Beta Pi, and she's a registered professional engineer in Colorado. Caroline?
Thanks. So as Paul just mentioned, I've done engineering throughout the Southwest, and there have now been 2 presentations that have talked about places in Colorado I have lived. Steve was showing a bridge that was about a block away from one of my apartments, and the watershed mitigation approach presentation yesterday, I live in that watershed. So that's actually where I grew up. Okay, so today we're talking about incised channel evolution theory and engineering geomorphology and erosion mitigation. So I know everyone finds theory the most gripping part of any presentation, so we're gonna start with it. If it lets me go. Come. It doesn't like me. Oh. I'm not allowed to go to the next slide, apparently. Haha, I will just do this old school. Okay, so you can see this whole list of people that worked on this project. This is a part of the task order with District 6 through the NMDOT. I sit in Colorado, but I do a lot of work in New Mexico. Stu Trabant actually put this presentation together. He is our resident geomorphologist, but he couldn't be here today. So instead of the geomorph, you get the hydraulic designer. Burke Loki is the head of the NMDOT Drainage Design Bureau. Usually he would be at this conference. He sends his regards. And Erica Newman represents the district in which these took place. Okay, so what is the incised channel evolution model? We have a beautiful picture. Essentially, it is a way to represent what happens and how channels incise, as the name suggests. So moving from classes 1 and 2 all the way through to class 6, most of us in this room have probably seen examples of these happen, and if you're looking at one location over time, it will kind of move through. If you don't touch it, it will be able to reach its own quasi-equilibrium. But the other thing of note is that you'll often see all of these classes, or most of them, in one profile where you're having incision problems. The big takeaway is it has to do with your critical bank height, which unfortunately is really defined as the bank height at which things start happening. So sorry, it's not the best defined variable. You should call Stu and he'll explain it much better than I can. But yes, what was cool for me, being a hydraulics person who's done erosion mitigation and not geomorphology specifically, was that I have seen all of these, and I could tell you, oh, yeah, I've seen degradation, I've seen when it's degrading and widening and slumping, but I didn't realize that there was actual theory behind it. Okay, so let's talk about this project. There were 3 sites that were looked at, and site 1, this is the one time we're gonna talk about it. Site 1 was just culvert outlet erosion. It was local scour, tried and true, not a ton of geomorph involved. But site 2, which is shown on the left here, has massive head cutting that you'll get to see in a minute, and also some of the bank erosion is threatening Highway 124. Site 3, you can see that beautiful bend. That lateral migration is starting to threaten New Mexico 197. Okay, so let's talk about geomorph. For site 2, we divided it into geomorphic subreaches. You can see them in plan view. Flow is moving from north to south, but also you can see this great profile. And when I said there was a massive head cut, yeah, I wasn't kidding. This location was a great application for the ICEM because You may notice the profile looks suspiciously similar to the idealized ICEM profiles. That was further indication that this was a good place to apply that theory. So the upper photo is looking downstream and the lower is looking upstream. We are talking 15-foot high vertical banks, and you can see the power poles. Yeah, people in New Mexico are going to be really excited if those fall into this unnamed wash. One important thing to also take note of is in this lower photo, you can really see that there are two major flow paths that water could be taking. The highway in the lower photo is on the left, so there's one closer to the highway and one farther. Going a little bit farther upstream, this is Erica. This is the one time she appears. There is a secondary head cut and only 6 foot high in Sediment, not 15. But there is evidence that this is going to continue to cause a problem. It is posing an imminent threat to the highway, both through widening and incision. But if you go downstream, if I started with these two photos, you'd be like, Caroline, there's not an erosion problem there. These look great. This is the transitional zone below the head cut, and there's actually evidence of aggradation there. So just downstream of where these photos have been taken is a major confluence with Water Canyon. I'm not kidding, that's its actual name. And the area just upstream has reached quasi-equilibrium. It's that nice class 6, kind of the river has, or the wash has balanced itself out. I'm going to put a pin in that and hop over to Site 3. Site 3 is off of Torian Wash, and this is historically incised. When I say historically, we're talking on a geologic time scale, not, we're talking hundreds of years, thousands of years, not, on the order of decades. It currently is at a quasi-equilibrium because of all of the bedrock and terraces in the area and the fact that this has been able to stabilize itself for so long. In these photos, first off, you can really see the beautiful New Mexico sky, but also you can see, especially in this bottom photo, which is right on the bend, how sharp that bend is and how much degradation has happened over there. However, most of this reach is our nice stage 6, and it's going to come back, which you may remember has our terraces, our floodplains, and aggradation has allowed it to kind of self-stabilize. Looking right at the bend, upper photo's looking upstream, lower's looking down. It's a very sharp bend. And also the right bank is prograding, which means that in addition to the left bank continuing to kind of eat out at the terrace, there's aggradation happening on the other side of the cross section, so it's forcing the bend to get sharper and sharper. You can also really clearly see some of the geotechnical failures. You can see some of the like the slumping. You can see some nice pieces of rock that look like they've fallen. This is definitely a kind of textbook bend problem. But if you go upstream a little bit, again, I think if I showed you some of these photos, you'd be like, oh, there's a little problem, but this is not a massive issue. There's not a lot of sinuosity except right here, but that terrace is actually a bedrock outcrop, so it's not going anywhere. And everywhere else, it's bounded really nicely by terraces and floodplains. And if you go downstream, same story. If I showed you the upper photo, there's not major erosion there. And that's because there's a lot of bedrock in the area. We have good base level control, so again, vertical erosion isn't as much of a concern. I love the picture with the shovel because I feel like everyone who's been in the field has used a random object for scale before, and I just enjoyed that this time it was a shovel. Okay, we're at a hydraulics conference, so we have to talk about hydraulics for a quick second. For these areas, we just used hydrology from stream stats, and for Site 2, which is shown on the right, we did a 1D RAS model. This area was so incised that there was no question about flow direction. We know where the water is. But for Site 3, where we wanted to really be able to understand the variation in velocity and shear stress through the bend, a 2D model was used. And now, this is why we're all here, right? Sediment. So the sediment transport analysis, instead of making a sediment transport model, we did sediment transport capacity rating curves, which are shown, they are discharge versus the sediment load or the sediment capacity. These, pulled from field data, pulled from hydraulic conditions, from our hydraulic models for those variables, and used MPM. I'm so glad that people already said it because I missay Mueller every time, and Toffeletti for the sediment transport functions. So what do these actually show us? They help us assess especially vertical erosion and identify the need for grade control from subreach to subreach. So for site 3, where there hasn't been a lot of evidence of further incision, it's already been incised, it seems vertically stable or at a pretty good vertical equilibrium. As we move between the different subreaches, their sediment carrying capacity is pretty similar. That is a really good indication that our idea that vertically there's not a lot of problems here is valid. We're not going to see a lot of sediment being picked up and dropped off as we move down the watercourse. But for site 2, the farthest upstream reach is the blue one. And then subreach 3 is actually the red one. We skip over subreach 2 because that's the head cut itself. And subreach 4 is the green one. So we're orders of magnitude different as we're hopping down the stream. And that reinforces the idea of seeing a massive head cut in subreach 2 because subreach 3 can carry so much more sediment, it's picking it all up. And then in subreach 4, we see that nice stable aggradation because the sediment carrying capacity has decreased again, so it's dropping out. Okay, so what do we do about it? This is the part that I love. Let's design something. We only put together conceptual designs, but for site 2, we need grade control, right? That's lots of vertical variability, lots of incision. So the major grade control structure is right at the giant head cut. You can see the nice giant red trapezoid. But also including some additional grade control downstream. That's mostly so that way we're not trying to construct a 50-foot deep grade control structure. That's just not feasible. But also wanting to reinforce some of the features that are already there to prevent further incision. Additionally, some of the areas of bank erosion that are threatening the highway, we're going to do one of my favorite things, just put some riprap on it. Simple, effective, and most people know how to construct it already. We did look at 2 different options, whether to do launchable riprap or a traditional revetment. So I told you to remember that there were 2 flow paths at the major head cut a couple slides ago. It's back. So in the cross-section up at the top, the highway would be on the right. This is looking downstream. There are 2 flow paths. If we're already going to go in there and build a structure, let's try to make it force water away from the highway. Let's try to reduce the lateral erosion as much as we can if we're already going in and disrupting. Placing the structures was based on equilibrium slope calculations, so that way ideally, worst case scenario, we will always have a somewhat stable, from a vertical perspective, channel. And you can see our wonderful sketches for the 2 different types of riprap stabilization. Obviously, advantages and disadvantages to both. I don't envy whoever has to try to get a truck down there to dump it. Either way, the DOT still has yet to decide what they want to go with. Site 3 had a completely different problem, which means it's requiring a completely different solution. Vertically, not a lot of problems. No grade control is needed. But with a bend this sharp, really the only thing you can do is realign the channel. However, and we'll look at the cross-section in a minute, traditionally we turn our channels into the nice perfect trapezoid that we all learned about in our hydraulics class in college, and that takes a lot of earthwork. And so in this situation, we didn't want to have to do that. Also, the DOT has had a lot of success in areas similar to this one with using sediment fences, and so they asked that they be included in this conceptual design. So I'm sorry if the contrast is not great, but the concept of terracing it is instead of, I'm going to having to grade from here to here. That's about 25 feet tall. That's a lot of earthwork. It's a lot of dirt to move. So instead, we're looking at terracing. So a 2-year low flow channel would be cut in, which is here. And then from that 2-year water surface elevation, that elevation would essentially be carried over as a terrace. And so you can follow the green line and then the gabion walls, which are represented on the left, it'll kind of zigzag up. And those breaks were set at the 2-year, the 10-year, the 100-year, and halfway between the 10 and the 100. So as part of this project, we also wanted to be able to give the DOT some recommendations on assessing erosion problem areas in the future. You know, they are the ones who are boots on the ground looking at this stuff every day. So it's not super great if they have to call me and Stu every time they want to just know what's happening. So our recommendation was, first off, you need to be able to identify what's happening. And when we say desktop evaluation, we're talking Google Earth imagery, we're talking, you know, being able to just look at kind of that publicly available data and take a shot at what are the hydraulic controls. Is it a bend? Is it culvert scour? Is it a massive head cut? What's going on geologically? Do you know there's a lot of bedrock in the area? And so being able to do a preliminary assessment of all of those things to, you know, try to just give you a starting point. Then nothing beats when you're talking about sediment getting to go there, because then you get to touch it and actually see what it is. Also, I've done a lot of work in deserts, Arizona, New Mexico. We love vegetation because trees can't grow without water in the middle of a desert. So if there's green, there's water. That really helps us understand where are our low flows, where are our typical flows, where can stuff actually grow. And being boots on the ground, you can really understand up close and personal what some of those driving features are that might not be apparent from kind of a high-level aerial. Then H&H, right? Everyone's fan favorite. But from that point, you get to decide if you need a sediment transport analysis. Maybe you don't. Maybe it's culvert outlet scour, in which case, you know, building a beautiful sediment transport model, while I think that sounds fun, might not be within budget or scope, and it might not be necessary in order to kind of put a Band-Aid on the problem. For some of these, just looking at sediment carrying capacity was sufficient, but everyone has been presenting on other projects where a full 2D sediment transport analysis was warranted. And then from there, we can, you know, recommendations and conceptual designs could be recommended. So you can see the contact info for all of us. I can tell you from experience that if you want to nerd out about geomorphology, that is genuinely how Stu loves to spend an afternoon, so please reach out to him. Again, if you have questions more from the DOT side, that you can feel free to ask me, but if I don't know, Burke and Erica are the people to reach out to. But that's it. I talk pretty fast, making up some time here, so that's it for me.
Any questions for Caroline?
Oh, sorry, you two are right next to each other.
You talked a lot about the different, I guess, observations of the geomorphological conditions. Did you kind of look at what was causing some of those things? Was it the road, or were there some sort of just natural processes that were driving those changes? Because you're proposing to correct them, and I'm just wondering what the root cause was.
Yeah, so especially for Site 3, it was really a natural process that, you know, as you went back kind of in historic imagery, that bend was already forming and starting to move closer to the road. And so it was more like, oh, that probably wasn't a problem when the road was built, but now it is. Site 2, it's a little bit harder to tell. The road probably made some things worse, but also there's so much happening there with a confluence and some culvert outlets kind of pinning down. Was this the road's fault? Was it the culvert's fault? Is it just an unstable area hydraulically? It was a lot more difficult.
And I question is, you mentioned that the critical bank height is the key for the stability of the channel. I agree, but the question is, how do you determine the critical bank height? Do you do a upslope stability analysis, like a very strict geotechnical, based on cohesion and internal friction angle, or is that something else?
That is going to be one of the times that I say, I don't know, and you should talk to Stu. He will be able to answer that far better than I will.
I know Stu personally, but I work with that.
Oh, excellent. Then you also know to know Stu is to love him, so he's an excellent person to help out.
Just very quickly, you know, in Colorado, we have a lot of gabions. They're more legacy. And I've heard different opinions proffered about the longevity of gabion baskets in different environments. So the environment that you're working in, what would you say, are there any risk factors to using the gabions versus like a sheet pile wall or some other different type of structure?
Yeah, so gabions are definitely, in some ways they're risky, right? Because if they fail, it's not just an erosion mitigation failure, it's a structural failure. But because of where in New Mexico these are, it's really a material availability and ease of construction question. Gabions are really, really commonly used in New Mexico. So I know from working in Arizona previously, sometimes if you want to put in gabions, the big limiting economic piece is finding someone who can do it and do it right. And in New Mexico, we don't run into that as much. So yes, I agree that there are definitely situations where gabions might not be the best choice, but for us, it's a lot of gabions. They're kind of tried and true down there. Thanks, everyone.
Thank you.